Hi, today we will go into chapter 18, Carbonyl compounds. So we have aldehyde and ketone under carbonyl compounds. So we will go into the reaction of aldehyde and ketone with HCN and with the presence of NaCN or KCN. So we will also describe the mechanism of the nucleophilic addition reactions of aldehyde and ketone with HCN. So first of all, we will go into description of carbonyl compound. So carbonyl compound is functional group with C double bond O. So where the C double bond O is bonded to H or R, the other side will be H or R as well. So where R is actually the alkyl group, where is the carbon chain. So if we are having a C double bond O that is bonded to OH, it is not a carbonyl compound. It is a carboxylic acid actually. So we have aldehyde and ketone under carbonyl compound. So what's the difference? So we could actually see for aldehyde is actually the C double bond O with at least one H bonded to. So for example, we have here C double bond O bonded to one H. And the other side could be H or R, like here we have CH3. So the naming of aldehyde is end with A-N-A-L. So let's make this as an example. So we have the longest carbon chain with two carbons. So two carbons, if it is an alkane, we will name it as ethane. So for aldehyde to go, so we got to end it with Al. So then we will have ethanol as a name for an aldehyde with two carbons. So next to go, we have ketone. So ketone is actually C double bond O that bonded to no H. So there will be no H bonded to. So we have an example where we have this C double bond O is bonded to 2R. So the naming of ketone ends with A-N-O-N-E. So then here we have this as example. So we have actually 3 carbons in this ketone, and we will name it as propanon. So we have the prefix prop for 3 carbons in the longest carbon chain, and the name ends with A-N-O-N-E. So we have propanon here. So next to go, we will go into the chemical reactions of carbonyl compound. So we have nucleophilic addition reactions for carbonyl compound. So since carbonyl compound is unsaturated, where carbon is with the double bond O, so it undergo addition reaction. And the type of addition reaction for carbonyl is nucleophilic because it is reacting with nucleophile. So let's go in detail for it. So here we have the reactions with HCN, hydrogen cyanide. So we have the reagent HCN. And next to go, we will have the condition where we need to have HCN, it's NaCN, KCN or NaOH as the catalyst. So they are the catalysts. So please do not confuse the reaction that we have learned for halogenal alkane. So for halogenal alkane to go, we have KCN as the reagent. So there will be nucleophilic substitution. The Cn minus will substitute the Cl, and we will have CH3CN as the product. But for carbonyl compound to go, the reagent will be HCN. but we have NaCN or KCN as the catalyst. So we cannot react carbonyl compound just with NaCN or KCN like what we have for halogenyl alkane. So we need to have hydrogen cyanide as the reactant. And where NaCN and KCN, they are just the catalysts. So for this addition reaction to go, where we have nucleophilic addition to go, so we will see actually the H is added to the oxygen of the C double bond O. And next, we will have the CN is added to the carbon of the C double bond O. Okay, so now this reaction will be the same for both aldehyde and ketone. So they will react with HCN to produce a compound with alcohol, OH, and also CN, nitrile. So this is actually a hydroxyl nitrile. So let's go for the naming for it. So first of all, we have to find the longest carbon chain. So the longest carbon chain here is with 3 carbons. So then here, we'll make CN as the main functional group, and where we will have the OH as a branch. So if OH as the branch, so we will got to number the longest carbon chain, 1, 2, 3, where we make the carbon of the nitrile as the first carbon, and we will see that where the OH is actually bonded to the second carbon. So therefore, the naming, we will have 2-hydroxy, where the OH as a branch, and the prefix will be prop for the longest carbon chain with 3 carbons. And we name the nitrile as propane nitrile. So where we have the name 2-hydroxypropane nitrile for this hydroxyl nitrile. So next, we will have to go into detail for the mechanism for this reaction. So where here we will have the mechanism for nucleophilic addition reactions, where we make this ethanol and aldehyde as the example. So first of all, we will need to have the aldehyde. So where we will have the polar bond for the C double bond O. Since oxygen is more electronegative than carbon. So next to go, we will have the Cn minus from the catalyst. And the Cn minus as the nucleophile will give the electrons to the delta positive carbon. And where next, the C double bond O will be broken as a single bond. And here we go, the intermediate. So we will have a single bond for the oxygen to the carbon, and where we have oxygen with negative. And now here, the nucleophile Cn minus will be bonded to the carbon of the C double bond O, and the rest remain unchanged. So this will be the intermediate for the first step. And the next step, the second step to go, where here we come the Cn, HCN. So we will have delta positive and delta negative. So the next step to go will be the oxygen with the O minus in the intermediate to give electrons to the delta positive hydrogen of the HCN. And here there will be the breaking of the bond. So this step, we will get the hydroxyl nitrile as the final product. So where we will have the hydrogen added to the oxygen. And from this part here, we will actually see the CN minus reform. So we must always show that the CN minus reform, because catalyst is unchanged chemically. So sometimes there will be 1 mark for this where we show CN minus reform. So this is the mechanism of nucleophilic addition for carbonyl compound. It will be the same for ketone as well. Okay. So next to go, let's discuss this question where it is from May-June 2016, paper 2, variant 2, question 5C. So the question wants us to complete the reaction mechanism for reaction 5, where it's a reaction between an aldehyde with CN minus. So including relevant lone pair, curly arrows, where it shows movement of electrons, charges, and also partial charges. So these are the points important in mechanism. So first of all, we will have a delta negative, and delta negative for oxygen, since oxygen is more electronegative than carbon. And next to go, we will have the lone pair for the CN minus, where it acts as a nucleophile. So the nucleophile will give electrons to a delta positive carbon, and then there will be the breaking of this CO bond. So the first step will give us an intermediate. So the rest remain unchanged. So for the C double bond O, there will be breaking of bond to give us O minus, and then the nucleophile will be bonded to the carbon of the C double bond O. So then next to go, we will have H plus. Since there is no CN minus reform here, so we will just use H plus to react with the carbonyl intermediate. And next, we will see that the intermediate will give electrons to the positive. So here it forms the OH bond. So next to go, they want us to draw the two stereoisomerism for the product. So from here, we have two kinds of stereoisomerism, where we have cis-trans isomerism and also optical isomerism. So since there's no double bond here, so next to check, it's optical isomer. So we could actually find a chiral carbon here. So where we have a carbon, it is bonded to 4 different groups to go. So if it has a chiral carbon, so it will show optical isomerism. So here we go, we have to draw the optical isomer of the product. So we have carbon that bonded to 4 different groups, so where it will have tetrahedral in shape. So for drawing optical isomers, we have to show tetrahedral in 3D. So where we have the H, the CH2, CH3. So the optical isomer of it will be the mirror image of it. So where we have the same thing here, dotted line for the H, and the wedge for CH2, CH3, and last to go, we have CN. So here it goes, the optical isomers of the product. So last question to go, the question wants us to suggest why a mixture of 2 stereoisomers is formed by reaction 5. Why there will be a mixture of them? Why not just one or just this? So the answer is that we have to go into the mechanism. So for the mechanism to go, we can actually see where we have to focus on the carbon that the CN minus attached to. So looking at this, we could actually see the carbon of the C double bond O is actually with 3 bond pair and 0 lone pair, where the shape will be trigonal planar. So since the C double bond O is planar, means it is flat. Okay, so therefore the Cn minus could have equal chance to attach from both sides of a planar C double bond O. Let's see here. For example, so we will have a planar carbon, and here where the Cn minus, where it is a nucleophile, it could actually attach from the left hand side, or it could also attach from the right hand side of a planar C double bond O. See, it could come from the left hand side, or it could come from the right hand side. So if it is coming from the left hand side, so it will form this as a product. So if it is attached from the right hand side, we could get this as a product. So this is the reason why we will get a mixture of both of them. So for us to write as answer, so we could say that C double bond O is planar. So therefore, Cn minus has equal chance to attach from both sides. Okay, good. That's all for today.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.